Hello and welcome back at the FiNetLink channel. Today we will be focused at application layer part 2. The objectives of the material for the application layer is to explain the operation of application layer protocols in providing support to end user applications. We saw the application presentation and session where we explain how the function of the application layer, presentation layer, and session layer work together to provide network services to end-user application. We even explain how end-user applications operate in a peer-to-peer network. And now we will explain how web and email protocols will operate. We will explain how DNS and DHCP operate, and lastly, we explain how file transfer protocol operates. There are application layer specific protocols that are designed for common uses such as web browsing and email. When a web address or uniform resource locator is typed into a web browser, the web browser establishes a connection to the web service, and then the web service is running on the server that is using the HTTP protocols. Both Uniform Resource Locator and Uniform Resource Identifiers are the names most people associate with web addresses. To better understand how the web browser and web service interact, let's examine how a web page is opened into a browser. And for this, we will use an example. And it will go in 4 steps. At the first step, there is a browser that interprets the 3 parts of the Uniform Resource Locator. In this case, we are using this address, where the HTTP is the protocol or the scheme, 3w.cisco.com is the server name, and the index.html is the specific file name requested. At the step 2, the browser then checks with a name server to convert the www.cisco.com into a numeric IP address, which it used to connect to the server. The client initiates an HTTP request to a server by sending a GET request to the server and ask for the index.html file. And then at the step 3, there would be a response to the request where the server will send an HTML code for this web page to the browser. And at the last step, which is the step 4, the browser will express the HTML code and format the page for the browser windows. And that will be at the client, the web page. But we have to remember that we mentioned that there are 2 kinds of protocols. It was the HTTP protocol and HTTPS protocol. The HTTP is a request response protocol, and when a client, typically a web browser, sends a request to a web server, HTTP specifies the message types used for that communication. The 3 common message types are GET, POST, and PUT. For the GET, this is a client request for data where a client, a web browser, sends the GET message to the web server to request an HTML pages. POST will upload data files to the web browser such as form data, and the PUT will be for this uploads resources or content to the web server such as an image. Although the HTTP is remarkably flexible, it is not a secure protocol. The request messages send information to the server in plain text that can be intercepted and read. The server responds typically with HTML pages that are also encrypted. For secure communication across the internet, we use the HTTP Secure Protocol. It uses authentication and encryption to secure data is traveled between the client and server. HTTP Secure uses the same client request server response process as HTTP protocol, but the data stream is encrypted with transporter layer security or its predecessor, secure socket layer, before being transported across the network. And now we can go to the email. One of the primary services offered by an internet service provider is email hosting. To run on a computer or other end device, email requires several applications and services as it is shown here. Email is a store and forward method of sending, storing, and retrieving electronic messages across a network. Email messages are stored in a database on mail servers. Email clients communicate with mail servers to send and receive emails. Mail server communicate with other mail servers to transport messages from one domain to another. An email client does not communicate directly with another email client when sending email. Instead, both clients rely on the mail server to transport messages. Email supports three separate protocols for operation: its Simple Mail Transfer Protocol, Post Office Protocol, and Internet Message Access Protocol. The application layer process that sends email uses Simple Mail Transfer Protocol, and a client retrieves email using one of two application layer protocols, Post Office Protocol or Internet Message Access Protocol. Let's see each of those protocols one by one. Let's start with Simple Mail Transfer Protocol. With Simple Mail Transfer Protocol, message formats require a message header and a message body. Although the message body can contain any amount of text, the message header must have a properly formatted recipient email address and the sender address. When a client sends email, the client Simple Mail Transfer Protocol process connects with a server Simple Mail Transfer Protocol process on well-known port 25. After the connection is made, the client attempts to send the email to the server across the connection. When the server receives the message, it either plays the message in a local account if the recipient is local, or forward the message to another mail server for delivery. The destination mail server may not be online or may be busy when email messages are sent. Therefore, the Simple Mail Transfer Protocol spools messages to be sent at a later time. Periodically, the server checks the queue for messages and attempts to send them again. If the message is still not delivered after a predetermined expiration time, it is returned to the sender as undeliverable. And with the Post Office Protocol is used by an application to retrieve email from a mail server, as we mentioned. With Post Office Protocol, mail is downloaded from the server to the client and then deleted on the server. This is the default operation of Post Office Protocol. The server starts the Post Office Protocol service by passively listing on DHCP port 110 for client connection request. When a client wants to make use of the service, it sends a request to establish a DHCP connection with the server, as it is shown here. When the connection is established, the Post Office Protocol server sends a greeting. The client and the Post Office Protocol server then exchange command and response until the connection is closed or aborted. With Post Office Protocol, email messages are downloaded to the client and removed from the server, so there is no centralized location where emails messages are kept. And because the Post Office Protocol does not store messages, it is not recommended for a small business that needs a centralized backup solution. The most commonly version used from the Post Office Protocol is version 3. And as for the Internet Message Access Protocol, is another protocol that describes a method to retrieve email messages from the server. Unlike Post Office Protocol, when the user connects to an Internet Message Access Protocol capable server, copies of the message are downloaded to the client application as it is shown here. The original messages are kept on the server until manually deleted. Users view copies of the messages in their email client software. User can create a file hierarchy on the server to organize and store mail. That file structure is duplicated on the mail client as well. When a user decides to delete a message, the server synchronizes that action and deletes the message even from the server. There are other application layer specific protocols that were designed to make it easier to obtain address for network devices. These services are essential because it would be very time consuming to remember IP addresses instead of web addresses or manually configure all the devices in a medium to large network. The DNS protocol defines an automated service that matches resource name with the required numeric address. It includes the format for queries, responses, and data. The DNS protocol communications use a single format called a message. This message format is used for all types of client queries and server responses, error messages, and the transfer of resource record information between servers. It goes through 5 steps, and the first step is when the user types a web address into a browser application address field. And then at the step 2, a DNS query is sent to the designated DNS server for the client computer. And then we will go at the step 3, where the DNS server matches the web address with the network address. And then at the step 4, the DNS query response is sent back to the client with the IP address for the address of the user in the browser application address. And then at the step 5, the client computer used the IP address to make requests to the server. And that is about the domain name system. And let's see all those DNS message formats. Let's see all those DNS message formats. The DNS server stores different types of resource records that are used to resolve names. This record contains the name, address, and type of record. Some of these record types are as A for an end device IPv4 address, and S for an authoritative name server, Quad A for an end device IPv6 address, and MAX for an email exchange record. When a client makes a query, the server DNS process first looks at its own records to resolve the name. If it is unable to resolve the name by using its stored record, it contacts other server to resolve the name. After a match is found and returned to the original requested server, the server temporarily stores the numbered address in the event that the same name is requested again. The DNS client service on Windows PC also stores previously resolved names in the memory. Here in this table are shown the DNS DNS use the same message format between servers consisting of a question, answer, authority, and additional information for all types of client queries and server responses, error messages, and transfer of resources record information. And the DNS protocol uses a hierarchical system to create a database to provide name resolution, as it is shown here in this figure. The DNS uses domain name to form the hierarchy. The name structure is broken down into small manageable zones. Each DNS server maintains a specific database file and is only responsible for managing name to IP mapping for that small portion of the entire DNS structure. When a DNS server receives a request for a name translation that is not within its DNS zone, the DNS server forwards the request to another DNS server within the proper zone for translation. DNS is scalable because host name resolution is spread across multiple servers. The different top-level domain represent either the type of the organization or the country of the origin. Examples of top-level domains are the following. We have .com, a business or industry, .org, a non-profit organization, .au, Australia, and .co, Colombia. And when you configure a network device, one or more DNS server addresses are provided that the DNS client can use for the name resolution. Usually, the Internet Service Provider provides the address to use for the DNS server. When a user application requests to connect to a remote device name, by requesting DNS client queries the name server to resolve the name to a numeric address. Computer operating systems also have a utility called NSLOOKUP that allows the user to manually query the name server to resolve a given host name. This utility can also be used to troubleshoot name resolution issue and to verify the current status of the name server. Here in the figure, we use the NSLOOKUP command. The default DNS server configured for your host will be displayed. The name of a host or domain can be entered at the NSLOOKUP prompt. The NSLOOKUP utility has many options available for extensive testing and verification of the DNS process. And after we saw the domain name system for the IP addressing service, now we will go to the dynamic host configuration protocol. The dynamic host configuration protocol for the IPv4 service automates the assignment of IPv4 addresses, subnet mask, gateway, and other IPv4 networking parameters. This is referred to as a dynamic addressing. The alternative to dynamic addressing is static addressing. When using static addressing, the network administrator manually enters IP address information on the host. When the host connects to the network, the DHCP server is contacted and an address is requested. The DHCP server chooses an address from a configured range of addresses called a pool and assigns it to the host. And when he assigns it to the host, it means that he leases this IP address to the host. On larger network or where the user population changes frequently, the DHCP protocol is preferred for address assignment. New users may arrive and need connection. Others may have new computers that must be connected. Rather than use static addressing for each connection, it is more effective to use IPv4 addresses assigned atomically using the DHCP protocol. DHCP can allocate IP addresses for a configurable period of time called a lease period. This lease period is an important DHCP setting. When the lease period expires or the DHCP server gets a DHCP release message, the address is returned to the DHCP pool for reuse. Users can freely move from location to location and easily reestablish network connection through the DHCP protocol. As it is shown here in this figure, various types of devices can be DHCP servers. The DHCP server in most medium to large networks is usually a local dedicated PC-based server. With home network, the DHCP server is usually located on the local router that connects the home network to the internet service provider, as it here. Or here. And many networks use both DHCP and static addressing. DHCP is used for general purpose hosts such as end-user devices. Static addressing is used for network devices such as gateway routers, switches, servers, and printers. DHCP for IPv6 provides similar services for IPv6 clients. One important difference with the DHCP version 6 does not provide a default gateway address. This can only be obtained dynamically from the router advertisement message on the router, if you remember when we explained that on other topics before. And the DHCP protocol goes through some operation. And as it is shown here in the figure, when an IPv4 DHCP configured device boots up on a connected to the network, the client broadcasts a DHCP discover message to identify any available DHCP server on the network. And then a DHCP server replies with a DHCP offer message, which offers a list to the client for the IP address. The offer message contains the IPv4 address and the subnet mask to be assigned, the IPv4 address of the DNS server and the IPv4 address of the default gateway. The list offer also includes the duration of the list. The client may receive multiple DHCP offer messages if there is more than one DHCP server on the local network. Therefore, it must choose between them and send a DHCP request message that identifies the explicit server and list offer that client is accepting. Client may also choose to request an address that it had previously been allocated by the server. Assuming that the IPv4 address requested by the client or offered by the server is still available, the server returns a DHCP acknowledgement message that acknowledges to the client that the list has been finalized. If the offer is no longer valid, then the selected server responds with a DHCP negative acknowledgement message. If a negative acknowledged message is returned, then the selection process must begin again with a new DHCP discover message being transmitted. After the client has the list, it must be renewed prior to the list expiration through another DHCP request message. The DHCP server ensures that all IP addresses are unique, which means that the same IP address cannot be assigned to two different network devices simultaneously. Most internet service providers use DHCP to allocate addresses to their customers. DHCP version 6 has a set of messages that is similar to those for DHCP before. And the DHCP 6 messages, we have studied them. It is the solistic advertised information request and reply. And that was about the protocols for IP addressing services for the domain name system and the DHCP protocol. And now we will go with file sharing services. And with the file sharing services, as we learned in the previous topics, in the client-server model, the client can upload data to a server and download data from a server if both devices are using a file transfer protocol. Like HTTP protocol, email and addressing protocol, file transfer protocol is commonly used application layer protocol. And here we will go in more details about this protocol. The file transfer protocol was developed to allow for data transfer between a client and a server. An FTP client is an application which runs on a computer that is being used to push and pull data from an FTP server. Here in the figure there is some commands sent across the control connection. Data can be downloaded from the server or uploaded from the client. The client established the first connection to the server for control traffic using the TCP port number 21. The traffic consists of client commands and server replies. The client established the second connection to the server for the actual data transfer using the TCP port 20. This connection is created every time there is data to be transferred. The data transfer can happen in either direction. The client can download data from the server or the client can upload data to the server. And as for the messages, we have the server message block for the file sharing services. And the server message block is a client-server file sharing protocol that describes the structure of shared network resources such as directories, file printer, and serial port. It is a request-response protocol. All server message blocks messages share a common format. This format uses a fixed size header followed by a variable size parameter and data component. And there are three functions for the server message block messages. The first one is to start, authenticate, and terminate session. And the second one is to control file and printer access. And the last one is to allow an application to send or receive message to all from another devices. Server message blocks, file sharing, and print services have become the mainstay of Microsoft networking. With the introduction of the Windows 2000 software series, Microsoft changed the underlying structure of using the server message block. In previous versions of the Microsoft products, the server message block services use a non-TCP IP protocol to implement name resolution. Beginning with the Windows 2000, all subsequent Microsoft products use DNS naming, which allow the TCP IP protocol to directly support server message block resource sharing, as it is shown here in this figure. The server message block file exchange process between Windows PC, and it is shown here in this next figure. Unlike the file sharing supported by the file transfer protocol, client establishes a long-term connection to the server. After the connection is established, the user of the client can access the resources on the server as through the IP resources in the local to the client host. And the Linux and Unix operating system also provide a method of sharing resources with Microsoft Network by using a version of server message block called Samba. The Apple Macintosh operating system also supports resource sharing by using the server message protocol. And with this, we are ending all the information about the application layer. And remembering one more time, we saw the application presentation at the session layer and operation of each of those layers. We explain how end-user applications operate in peer-to-peer network, and now in the second material, we explain the web and email protocols, DNS and the DHCP protocol, and how these protocols operate. And then, at the last one, we explain two main protocols for file transfer protocols as file transfer protocol and service message block. And with this, we are ending all the information about application layer, remembering you to subscribe this channel and hit the notification button for the new videos that will be uploaded. See you to the next session.